Sometimes it's not just about optimizing the cost and choosing the lowest cost infrastructure. It's about choosing the right infrastructure that helps you achieve your business goals and get to market faster. And that's why we encourage customers to think about, performance adjusted costs, the cost of supporting infrastructure, and these intangibles.
Hello, everyone. Welcome to the AI Cloud Horizons podcast, where we talk about key topics in the world of AI and the people building the infrastructure behind it. My name is Harsh Banwait. I'll be your host for today. And I've got Urvashi Chowdhary here with me, who is VP of Product Management and AI Services at CoreWeave as well. Here at the AI Cloud Horizons podcast, we talk about the future of AI and talk to people that are building the infrastructure behind it. And today we're here to talk about a very important topic that's on the minds of CEOs and CFOs at a lot of the leading AI companies, and that is total cost of ownership. So welcome, Urvashi. Thank you for being here with us.
Thank you, Harsh. I'm really excited to dig in.
Why don't you go ahead and tell us a little bit about yourself?
Well, I'm really excited to be here and have this discussion today. I'm Urvashi. I lead product for our AI services at CoreWeave, and I've been here just under 6 months and loving every minute of it. Prior to CoreWeave, I spent over a decade at Amazon, where I was building the AWS machine learning platforms and services. And before that, I spent time in strategy, business development, and engineering roles in the cloud. Throughout my career, one thing that I've really enjoyed is working with customers and enabling them in their adoption of new technologies.
Awesome. Urvashi, what led you to talk to customers both at AWS and CoreWeave about TCO?
Yeah, so throughout my career, what I noticed was that technology is evolving really fast and technology teams are adopting these new innovations at a really fast pace. However, some of the supporting functions and decisions, such as how we think about technology investment and purchase decisions, how we work with cross functional stakeholders like finance, IT, procurement to invest in these technologies. Some of those supporting functions and decisions weren't moving at the same pace.
Mm.
And so I really started to think about how we can evolve our decision-making process and a framework for thinking about costs and investments in a way that was more future-proof and in line with the evolution of technologies.
What do you mean by future-proof?
I'll give you some examples. So early on, when I was working with customers who were moving from on-prem to cloud, it was helping them think about their technology investments and the costs from a OpEx standpoint instead of CapEx, which was the traditional way of thinking about these costs. When I was at AWS, I worked very closely with customers to help them think about build versus buy decisions in using managed services for AI infrastructure and platform versus building everything themselves for faster speed to market.
Mhm.
And then when I joined CoreWeave and I was talking to customers and joining some of our sales teams, I noticed that a lot of the discussion was focused on the GPU pricing,
Mhm.
and which is understandable because these are large investments. However, the pricing alone and the older way of thinking about infrastructure costs in terms of usage and price of the unit costs wasn't really giving customers a full picture of their overall costs or TCO. So that
Yeah.
led me to starting some discussions internally and working with our teams and customers to start building a framework around how we might want to think through these costs.
Before we go any further, I think we should align on what do we mean when we say TCO?
Yeah. So let's take an example. Say you were looking to buy a new car, and this would be your daily driver, and you're going to put a lot of miles on it. You're not just going to look at the cost of what you paid to buy this car. You may also want to factor in other costs like the fuel efficiency, the cost of maintenance, the reliability of the car, insurance costs. And so all of these costs together, along with the price that you purchase, help you think through the total cost of ownership for that car over a period of time that you might be owning it. And this overall cost might be much higher or different than just the cost that you pay when you make that initial purchase. So for AI infrastructure, we may want to think through the broader cost versus just the initial cost.
I like that analogy because, well, firstly, customers in this space aren't just buying like a little minivan or pickup truck; they are buying essentially a supercar.
Yeah.
Um,
Or a
the-
Formula One.
yeah, exactly. Like the amount that they're spending as portion of their entire company spend is pretty substantial. So any little cost that they can help shave off, it goes quite a long way in terms of like extending the runway.
Absolutely. And, with AI becoming so central and poised to be the next, technology that's going to disrupt many of the current workflows that we might have, these AI costs are starting to be a large portion of customers' bill or expected to be a large portion of their investment.
Okay. Let's take it a step further. So if it's not just about, dollars per GPU per hour, what should we look at?
Yeah, a common misconception or assumption I've seen people make sometimes is that a GPU across cloud providers or a cluster of GPUs across cloud providers delivers the same performance.
Mhm.
And so, all else being equal, you can think about the cost as just the sticker price or the dollar per GPU that you might be paying across cloud providers. Um, I think that assumption does not give us the full picture and the true understanding of the cost, because what we really should be thinking about is the performance adjusted cost. Because these GPUs and clusters of GPUs across cloud providers are not delivering the same level of performance or reliability that is required for AI workloads. So the overall costs might end up looking very different
Mm,
than just the sticker price of the GPU.
makes sense. Do you have a high level framework or how do you think about it with performance and anything else?
Yeah. So one framework that we've developed internally, and we've been talking to customers about it,
Mhm.
which seems to be resonating well with them, is really thinking about the total cost of ownership for AI workloads in three buckets. The first is the performance adjusted cost of the GPU infrastructure itself.
Mhm.
And so here we factor in things like how well the GPUs are operating, how reliable they are, their uptime and utilization.
Mhm.
The second bucket is the supporting costs for infrastructure. These are typically storage, networking, observability, and support costs
Mhm.
to make sure that your clusters and your GPU infrastructure remains well utilized. And finally, the third bucket that in this framework we encourage customers to think about are these business intangibles. So those might be your business goals around time to market, keeping your researcher productivity high, and having a cloud provider that is supporting you in your business goals in meeting these.
That makes sense. I think that sounds like pretty holistic view of how to think about costs, especially the intangible piece. I want to dig into that a little bit later. But Urshi, let's get a little bit more specific, right?
Okay.
Like, we're talking about AI workloads. A lot of customers that might be listening to this uh, are potentially, training their own model, maybe fine-tuning a model. Specifically when it comes to model training, like how should a customer think about their TCO?
Yeah. So first, let's talk about what AI training looks like and why it is different from any other application like a traditional web hosting or search or database. If you're a foundation model lab and you're building your next large language model, you're typically working with lots of data and with a cluster of hundreds or thousands of GPUs connected. And all of these GPUs need to work together
Mhm.
to train your model. And this process of training can take days, weeks, or even months, depending on the complexity of the model and the level of quality that you're trying to achieve for this model. And during the training process itself, these thousands of GPUs with millions of connected components, including compute, storage, networking, memory, cooling. All of these components are working 24/7 to process your data, train the model, constantly share data and state with each other. And so they're working really hard, almost 24/7 to complete your training job.
Mhm.
And very similar to, a Formula One car where the car's under extreme stress in these really intense conditions and they're being pushed to their limit. These GPUs and related components are being pushed to deliver maximum performance. And they're grinding really hard. And it's very common to see some components fail or take a break. And when an interruption like this happens, your entire training job stops,
Mm.
and you have to wait until that issue is resolved and your cluster is back up and healthy in order for you to start your training job again. So if you're trying to build the next state of the art model and these interruptions occur, it slows down the training process. It leads to, times when your GPUs are idle while your cloud provider is figuring out these issues or fixing them and getting the cluster back up. And in the meantime, you're continuing to incur costs and your researcher productivity slows down. And overall, your jobs might take much longer to complete. So that's why it's important to think about performance, not just the initial cost in training.
That's very interesting to think about. Like a single failure could essentially render tens or hundreds of millions worth of infrastructure next to useless for as long as we cannot like either fix that failure or get the rest of the infra going.
Yeah,
That's pretty wild.
it is. And this is where, if you just think about the GPU price, and if you're getting, say, a 25% discount, but your jobs are taking twice as long because the reliability is not where you need it to be, then your overall costs are going to be much higher.
Yeah, and I think this is also like where going back to your car analogy, one thing I like to talk to customers about is that you can have a very nice car, you could have paid a really good price for it, but if your car is constantly in the shop, it's not worth that much to you.
Yep, that's a great way to think about this.
Awesome. Urshi, thank you for that example. Training is one part of the workloads. A lot of customers are also serving models. Like, how does TCO calculations change when we're thinking about inference?
Yeah. So inference is where you use the models that have been trained, and those models start serving millions of customers or powering your enterprise and business workflows. So inference is really where these models are coming to life. And unlike training, inference is not massively parallel or is more elastic. However, the performance and reliability for your AI infrastructure for inference is still the most important thing that customers often care about. Because when you have custom end customers using your models, you want to make sure that your infrastructure is delivering the lowest latency, it's able to scale to the demand that you're seeing, and your teams are not spending too much time managing the infrastructure but really innovating. In my prior role at AWS, I build and scaled inference services. And a consistent sentiment that I heard from customers was that if the inference infrastructure is not performant and reliable, the impact that they experience from an end customer standpoint in terms of loss of customer trust or not being able to serve demand or the lost business revenue is far greater than the cost of the infrastructure itself. So I would say both for AI training and inference, thinking through the total cost of ownership with that lens that we just talked about is important.
Yeah, I think that's really interesting because especially right now when there are a lot of models that like overnight can become a complete hit. And if you're not able to scale them, there might be a demand, but if customers aren't able to essentially use them, customers might feel underwhelmed, might feel underappreciated that this company or this application wasn't ready to serve us.
Yeah, you've got that right.
So I think it makes sense that performance adjusted costs is a better way of looking at TCO. Uh, what have you seen in terms of the people or companies, when they make that switch internally, like how do they start viewing TCO differently?
Yeah, I think the biggest switch that I've seen happen when we start talking about performance adjusted costs and all of the other um, parts of this framework that we talked about is that cross-functional teams that are making decisions around AI infrastructure investments, they start to appreciate the nuance of AI workloads. Some of the things that we just talked about with training and inference that are different. And they also start to appreciate the fact that a dollar spent across cloud providers does not equate to a dollar in value that they receive, based on the performance and reliability and some of the other factors that go into the overall cost. So really, we spend time with customers thinking through performance adjusted costs, the cost of the supporting infrastructure, and then the intangibles around speed to market, and yeah.
Awesome. I've talked to a few customers, and whenever we're talking about TCO, GPUs are always like the center of attention in terms of cost, but they're not the only costs that customers incur when, they're looking at their bill. Like there's other things that are potentially could be a line item too. What are some of the other costs that customers traditionally overlook when they're doing the TCO calculation?
Yeah, so GPU costs do tend to dominate majority of the discussion. However, there are other costs that we also try to bring to the surface in our discussions. Um, when you're paying so much for these advanced GPUs and sophisticated hardware, the last thing that you want is that your GPUs are bottlenecked by memory, data, storage, and networking. So, when you factor in all of these requirements to keep your infrastructure performing to its maximum, we encourage customers to think about the other costs that might be not coming to the surface. So, for example, for storage, you might incur not only storage costs, but also data transfer costs,
Mhm,
egress, ingress, request IOPS.
mhm,
For networking, you may incur costs around data egress, ingress, and then NAT gateways, load balancers. For observability, you may incur costs around the amount of data that you are logging and the number of metrics that you might want to see.
mhm,
And all of these costs, they start to add up.
mhm,
And the other big cost that can also be overlooked is around enterprise support.
mhm,
And I think it's common in multiple cloud providers to apply a flat or a percentage of the overall contract cost as enterprise support.
mhm.
But we also need to think about what enterprise support looks like for AI workloads and really how it needs to also be evolved, and it needs to support these advanced workloads. Uh,
That makes sense. Uh, these like storage, networking, support costs, like how do they change for people that are potentially building at scale? Because at scale, I'm sure there's other problems too.
Yeah, it depends on the size of the cluster and the amount of data that you're using. But what I've seen is that these additional supporting infrastructure costs can go anywhere from 5% of your overall cost to 15% of your overall costs. So they can be sizable, and we should be thinking about these as well. On the enterprise support piece, I do want to give a shout out to the previous episode of
Mhm,
this podcast where John Mancuso and Jacob Feldman talked about enterprise support and SLA in the evolving AI workloads. So it sets a really good stage for how enterprise support, what sort of enterprise support we need for AI infrastructure.
So Urvashi, you mentioned enterprise support. How should a customer think about that as part of their TCO?
Yeah, like I mentioned, it's common to apply a flat fee or a percentage of your overall contract cost towards enterprise support, but you need expert support, and um, you want to make sure that your support model moves as fast as you want to move on your business goals in terms of like training your AI workloads. So if you're training a large language model and you are experiencing interruptions, you really want your cloud provider to be able to quickly detect and resolve these issues. And you don't want to be stuck at the end of a long support queue trying to just connect with experts. So, if you haven't seen the previous episode of this podcast, I highly encourage you to take a look at it because it really goes into what enterprise support and SLA means for AI workloads.
Awesome. Yes. And shout out to John Mancuso and Jacob Feldman. If you have not checked out episode 2 of AI Cloud Horizons, we definitely ask you to do that on our YouTube channel. Um, one last thing on, we're talking about scale. The one thing that I think like customers should also know is that when you are operating at scale across regions, some of these costs start to compound. Because if you're thinking of talking to your own cluster across regions, you're going to have to like go over the public internet or a backbone at times. And in some cases, these egress costs can multiply just your GPUs and your infrastructure talking to each other.
That's true. Yeah. So this is where thinking through not just the GPU costs, but the supporting infrastructure costs is important.
Awesome. So Uruchi, thank you for that. I think that makes sense. A lot of what you have talked about so far is around performance, reliability, some of the intangibles like speed to market. I want to hear from you, like, how do you do it differently at CoreWeave?
Yeah, super happy to talk about that. I think there's three things that are different about how CoreWeave handles this. First is CoreWeave is designed from the ground up to be a AI cloud. What that means is that every decision that we make around our infrastructure, our platform, and our application services is all to accelerate AI training and inference workloads. So we're not trying to optimize for general purpose compute. We're really focused on building that Formula One for AI workloads. The second part that is different is that we have a lot of automation in place through our CoreWeave mission control. What that basically does is it monitors every component of our infrastructure and gives us detailed insights into how it's performing. We can quickly detect issues such as individual GPU temperature changes or InfiniBand bottlenecks, and that helps us quickly identify and troubleshoot issues and proactively detect and monitor the health of our clusters. So ultimately, customers see higher cluster reliability and uptime. The third thing that's really unique to CoreWeave and something that I absolutely love is our direct to expert support model. So our customers don't spend uh, hours or days getting in touch with experts. They connect with them within minutes. And because of all of the automation that we have and the deep observability, we're able to quickly detect and diagnose issues and provide hands-on support to customers to keep their AI workloads up and running and maximize performance. So I think all of these three things make CoreWeave a AI specialized cloud, and why some of the leading AI labs, startups, and enterprises work with CoreWeave.
Interesting. So you both like architected the products as well as your support model to optimize for time, to optimize for speed, which essentially, like in your words, helps save costs to the end customers by making them more efficient.
Yeah.
Awesome. Urushi, like I hear that, I love that, but I'm a data-driven person. I'm sure a lot of our viewers and our customers are too. So how do you quantify all of this for them?
Yeah. So let's take AI training and talk about two key performance metrics that we encourage customers to think about. The first is a model flops utilization, or MFU, and the other is goodput. Both of these metrics together give us a indication of how much performance are we actually deriving from our clusters for these AI workloads. So maybe we can talk about MFU first.
Let's do it.
All right. So MFU tells us what is the performance that is lost due to system inefficiencies? Because AI workloads are extremely complex. Even though the theoretical model flops utilization that you could derive is 100%, what we actually see across the industry is that MFU ranges between 35 and 45%.
Mm.
At CoreWeave, because of how we've designed our AI cloud platform, we're able to deliver 20% higher MFU, which means for the same workload, CoreWeave jobs run much faster for a like-for-like cluster. And there's a few ways that we are able to improve MFU, which is all around how we design our infrastructure.
But how do you actually go about improving MFU?
Yeah, so this goes back to how we build our AI cloud. So let's step through all of those layers. First, we build to NVIDIA's reference architecture, and we enable customers to run bare metal nodes through our CoreWeave Kubernetes service, which means no performance is lost through layers of virtualization that might be common across other cloud providers. So that's one. The second is connecting our GPUs. We use NVIDIA Quantum to InfiniBand for a multi-fabric network across our cloud to enable high performance, high throughput, and low latency interconnects when you are running large GPU clusters. So this really speeds up the communication and between your GPUs and reduces those bottlenecks. The third is through our deployment of NVIDIA Bluefield 3 DPUs. So these DPUs offload, accelerate, and isolate networking so that your GPUs are hyper-focused on just the computation and training tasks required. So across all of these layers, when you run your AI workloads and training jobs on CoreWeave, we're able to maximize performance and deliver up to 20% higher MFU through the way that we've built our system.
Yeah, that makes sense. And being a part of the compute team at CoreWeave, virtualization not just has tax on performance, it also has a tax on cost. So when we think about total costs of a server of your compute infra, virtualization, like that virtualization layer, can also add an incremental cost for our customers, which we essentially can save for our customers.
Yeah, and another impact of virtualization can also mean that customers don't have full visibility into their infrastructure. So because of our approach to have bare metal nodes, customers can see all of the infrastructure metrics that we're able to see, and they're able to monitor not just the GPU performance across their stack, but also performance around networking, storage. And because we can deliver all of these insights and deep observability on our end, CoreWeave has been able to automate a lot of this monitoring, and we're able to detect issues faster and proactively and fix them in many cases, even before they impact the jobs. Whereas with a different approach on virtualization, sometimes it can be hard to even understand where the issue is happening. And it's common to see it take weeks to diagnose an issue because you have to isolate where this issue is actually happening. And so through this approach, we're able to not only give customers full visibility into the infrastructure, but also use it to automate and detect these failures faster.
Yeah, I think like in a lot of these cases, we've seen customers are quickly able to tell, is it a hardware issue or is it an application layer issue? And they don't need to essentially wait on a response from CoreWeave for like whatever period of time before making a call on that.
Yeah, it just makes everything so much more efficient and helps us move fast towards the goal that we have, which is to bring these models to life faster.
Awesome. Urvashi, you mentioned one other metric initially. You talked about a little bit about goodput. Could you say more on that?
Yeah. So you can think of MFU as the performance that we are deriving from the infrastructure.
Mhm.
Goodput is a way to think about the effectiveness of the cluster when you are running your workload on them. So, if we take AI training, for example, we earlier talked about that there can be interruptions. So, during those interruptions, you're not effectively training.
Mhm.
And in order to quickly manage those interruptions, you might be doing additional tasks such as saving your model checkpoints into a local storage.
Mhm.
You might be loading those models from the checkpoint again to resume your job. So if you think about goodput or effective training time,
Mhm.
it's a percentage of the actual uh, time that is spent on training versus all of these other tasks like waiting for interruptions, model checkpointing, loading.
So I can think of MFUs as, is my infrastructure actually working? And Goodput as, is it working on the right thing? Is it working on the most valuable thing?
Exactly. And so we talked about earlier how CoreWeave delivers 20% higher MFU.
Mhm.
Similarly, for Goodput, we have seen industry average for large scale clusters of like thousands of GPUs to be at about 90%.
Mm.
Whereas with CoreWeave, we're able to deliver up to 96% Goodput,
Mhm.
which means more time of your infrastructure is actually spent in training the job, and we're able to accelerate some of these other tasks so that you can train your model faster.
Got it. So how does one go about like increasing the Goodput of their info?
Yeah, happy to share how we're able to improve this goodput. First, it stems from our CoreWeave mission control.
Mhm.
So even before we enable customers to run their jobs, our teams stress test and do a lot of comprehensive burn-in testing to make sure that our clusters are up and healthy, and every single one of those components that would be part of your cluster are delivering to their maximum performance. And so when we deliver clusters to customers, they are able to run their jobs on day one. So we've had many instances where customers wanted hundreds and thousands of GPUs to be ready for training their models, and we were able to enable them on day one itself because of this comprehensive testing. Now, as the jobs are running through mission control, we have a lot of automation in place through our fleet lifecycle controller, our node and rack lifecycle controller, where we monitor all of the metrics and components across the cluster, including GPUs, memory, networking, and storage, to be able to quickly identify and resolve any issues that might happen. So we've seen that our CoreWeave infrastructure can deliver higher utilization and deliver 50% lower interruptions
Mhm.
for like jobs and cluster sizes across the industry standards. Ultimately, that means higher cluster utilization rates and higher productivity for research teams. Um, so that's a big component of how we improve Goodput.
Yeah, I think like I really like that last point where, you know, researcher time is very, very valuable. I think we all understand that now. And as much time as we can save for them to like do the job that they're best at and for us to kind of like manage the infrastructure, the more valuable we can make them. I think there was like one customer that we had out of APAC that said because CoreWeave helped them improve their cluster utilization, that they didn't have to wrangle with infrastructure issues. I think they said somewhere around like 8x improvements in TCO
Yeah.
for them, which I think is a ridiculous like cost saving.
Yeah, absolutely. And there's more ways that we are able to deliver higher goodput. So the CoreWeave Sunk offering, which is Slurm on Kubernetes, allows us to run topology-aware job scheduling so that your jobs are placed on GPUs to deliver maximum performance and take advantage of those high bandwidth InfiniBand interconnects. And in addition to that, we are able to provide 5x faster model loading with Tensorizer. And so we talked earlier about how not only do we minimize the interruptions, but when these interruptions happen through Tensorizer, we can reduce the time that it takes to save the checkpoints as well as load from these checkpoints. And lastly, the CoreWeave AI object storage is really high performant and delivers 2 GB per second per GPU across thousands of clusters and scales really well, which means when you are saving these model checkpoints and retrieving them, the high performance storage with the local caching that we enable gives you all together, gives you higher goodput compared to industry standards.
Amazing. Always love when you can put like numbers and like products behind any of the claims. So appreciate that.
Yeah. And so when you combine the 20% MFU improvements and the 6% goodput improvements that you see on CoreWeave for the same GPU type or infrastructure compared to other cloud providers, we're able to deliver through these improvements up to 25% higher T-flops per GPU, which means your jobs are running much faster, you are getting to market faster, and your overall costs are much lower.
Which that makes sense. One last thing on this is, earlier you talked a little bit about things like storage, networking, technical support. How does CoreWeave handle that?
Yeah, so we talked earlier that we also need to consider the supporting costs. So with CoreWeave, we don't charge for many of those, which directly translates into cost savings for customers. Let me break these down. First, we do not charge for support, and every customer receives direct to expert support and hands-on technical support from our teams. Second, with our CoreWeave AI object storage, we don't charge for data egress, ingress, request IOPS, and we deliver 6 to 70 terabytes of local NVMe storage included as part of our clusters. Third, when we look at networking costs, we don't charge for data egress, ingress, NAT gateways, load balancers, and we do not charge for our CoreWeave Kubernetes service control plane. And lastly, for observability, I mentioned how we deliver, what we call metal to application observability through our observability platform, but we do not charge customers for the amount of data that they're logging or metrics that they might be charged for another cloud providers. So all of these directly translate into cost savings for customers and lower overall TCO for them on CoreWeave.
Awesome. I appreciate that. So like, higher, more performant infrastructure, not charging for these additional line items like egress, ingress, IOPS, all of those like little things that can potentially like add up to, as you mentioned, like single digit percentage points.
Yeah.
And also like offering support so that our customers feel empowered. They feel that they understand the infrastructure and that they feel that their cloud providers like with them along the way in case they face any issues.
Absolutely. And, AI workloads are complex, and we have many customers where they have the best research minds working on a problem, but they may not have large infrastructure teams managing their platform. And that's where they love to work with us because our team not only manages the infrastructure and delivers a really high performant and reliable cluster, but we also partner so closely with them in monitoring, detecting issues, and advising them and almost working as an extension of their teams instead of sending them through a traditional support channel.
I want to switch gears a little bit because you mentioned intangibles early on in our conversation, and I want to hear a little bit more on that.
I think when we sometimes focus a lot on the cost, these intangibles like speed to market, researcher productivity, and getting your models in the hands of customers can sometimes get lost, but that's extremely important. Up until 2024, the average time between new state-of-the-art model launches was about 100 days or so. And now just over the last few weeks, we've seen these new models coming almost daily, and then sometimes multiple models launching every day. So if you're an AI lab or an enterprise that's building the next state of the art model, and you have a team of researchers that's focused on being first to market,
Mhm.
it's really important to have a cloud provider that's matching your ambition and partnering with you in enabling you to operate at the speed that you want and being able to deliver not only great performance, but give you an advantage in those intangibles.
You know, CoreWeave talks a lot about like things like speed to market, uh, efficiency for our customers. Like, what's at stake here? Why is that so important?
Well, everything is at stake if you're an AI lab trying to build the next state of the art model, or if you're a startup using these models to disrupt a space, or if you're an enterprise looking to reimagine your business workflows or um, end customer experiences, really makes or breaks your business at that point. So it's really high stakes and critical for businesses. For a lot of our customers, that benefit comes from having access to the latest generation of hardware. And it's one of the reasons why customers like Cohere and IBM and Mistral AI are working with us to be first in adopting the new GB200 NVL72 platform so that they can train their next generation models and save almost 2 to 2.5 times uh, the time it takes to build these models.
Yeah. When I think about this, I think like one of the other things that I think about is like iterative development. The faster you have access to something or the faster that you are able to release a model, develop a model, internally preview a model and figure out if it's the right direction or not, the faster you're able to essentially scale it, release it to your customers. And the longer you're essentially waiting, you're giving way to competition. You're making your, like, as we talked about researchers, you're making your teams wait on, essentially your infrastructure, and you're waiting to realize like what the results could be
Yeah.
potentially.
In we're in such an exciting time in the industry where there's so much innovation happening
Mhm.
that every iteration counts, and speed, time to market, maximize, enabling researchers to have the right platform and support to take their ideas and bring them to life is extremely important. And we focus a lot in enabling customers to do that. So one of the things at CoreWeave that we really focus on is being first to market with the latest accelerator types. And Harsh, you're on the ground floor there with the teams working hard through that. It's hard. It's hard to work with new hardware because um,
There's a lot of unknowns,
there's a
essentially.
there's a lot of unknowns, and it's a skill that we've developed over time, starting with bringing up the Hopper H100, H200, and then with the Blackwell GB200 and 300 now. So we focus a lot on learning and improving our own systems, our automation, our monitoring, and we apply those learnings in the next generation that comes out to bring it to customers before anybody else. And it's not just that we're standing up a single rack or two, we're actually delivering these racks at scale in production. In fact, one thing that I'm really excited about is the ML Perf submission that we did, where for the GB200 NVL72, CoreWeave was able to run the Llama 405B model and deliver really high industry leading results for both training and inference.
Yeah, I think like speaking as part of the team that's like working behind the scenes on a lot of these new generation instances, we have to operate with the same sense of urgency for our customers. Like,
Absolutely.
I am answerable to them. They are waiting on some of this tech to essentially either become more efficient or push the boundaries of AI. Like, in a lot of ways, CoreWeave is defining how AI is going to be operated and used at scale. and there's a chip on our shoulder to kind of essentially deliver on that.
Yeah, and it's translating to tangible results for customers. So IBM, Cohere, Mistral, they're all confirming that they're able to train their models 2x faster with the GB200 series. And it's exciting to see what customers can unlock with these innovations. So, yeah, going back to the TCO discussion that we had, sometimes it's not just about optimizing the cost and choosing the lowest cost infrastructure. It's about choosing the right infrastructure that helps you achieve your business goals and get to market faster. And that's why we encourage customers to think about, performance adjusted costs, the cost of supporting infrastructure, and these intangibles.
Makes sense.
Well, thank you, Harsh. I really enjoyed this conversation, but now we're going to see how well you've been listening to me. So we're going to get into a rapid fire round called TCO Truth or Myth. I'll make a statement about TCO of AI infrastructure, and you're going to tell me whether it's a industry truth or myth. So let's get into TCO truth or myth. All right. First, I'm getting $20,000 credits from cloud provider A versus 5,000 credits in GPUs from cloud provider B. So I should go with cloud provider A, right?
That does sound very tempting, but I'm gonna say no, myth. I think like you've taught me that we need to look at performance adjusted costs. We need to look at what kind of support I get, and we need to look at the intangibles of what I get out of that relationship too. So I'm gonna go with myth.
Good. All right. Second question. Data egress costs are just a rounding error in my overall costs.
I wish, but I'm gonna go with myth on that again. I think what you mentioned was that a lot of these costs, like data ingress, egress, IOPS, or could be like a single digit percentage point, if not more. So I'm gonna go with that.
Very good. All right. Third, premium support or direct to expert support is a necessity, not a luxury.
I'm gonna go with truth on that because I think like going back to your car analogy, what I was really thinking of it was I need a solid pit crew to get a podium finish. So if the team that I'm working with is not there by my side, if they're not skilled enough, I wouldn't feel confident. And I am operating pretty expensive, large vehicles slash infrastructure. So I'm gonna go with truth on that.
Very good. All right. Next question. You should always use the latest and greatest GPU for your AI training and inference workloads.
Oh, I can definitely speak to that. Coming from the computer world, definite. I'm going to say a myth. You know, newer generation GPUs typically come with a lot of performance and efficiency benefits, but in some cases you're not pushing performance, and your team will need to spend time on re-architecting their applications, getting used to the architecture. And in that case, like speed might be of the essence, and you might be good where you are. Go with what's working for you. Case.
All right.
Yeah.
Next question. GPUs are interchangeable, so I should just get wherever I'm getting them at the lowest price.
I want to say truth just to see your reaction and see you yell at me, but I'm gonna go with myth. I think if there's anything that I've learned, it's you have to look at the overall performance, efficiency, the team that's supporting you, and every provider can architect the same thing and support the same thing very differently. So you need to have all of that into consideration to be able to look at where to go.
All right, last and most important question. GIF or GIF?
Oh, good. Absolutely. Well, thank you so much, Urvashi, and thank you to our viewers for taking time out of their day from here from us today. If you're interested in learning more about TCO for AI infrastructure, we've dropped some links in the description. This is the AI Cloud Horizons podcast. My name's been Harsh. This is Urvashi, and we thank you for joining us. Hope you have a good rest of your day.